What's up, everybody? Mr. Sawiki here, and I can't wait to get started. I got a great problem to kick us off today. How many rows and columns does your array show? How many rows and columns does this array have? Kayla.
4 rows and 3 columns.
That's right. Ethan, we counted 3, 6, 9, 12. How does that array show the count?
Because 3, 6, 9, 12 is 4 threes. And this array has 4 rows of 3 circles.
Nice. How many rows and columns does the new array show? Kayla.
The new array has 3 rows and 4 columns. In the first array, the 4 threes were 4 rows of 3 circles. And in the second array, the 4 threes were 4 columns of 3 circles.
That's right. Ethan, did the total number of circles change?
Nope.
So, I'm hearing you guys say that the total and the factors stayed the same. The factors just switched places. Recently, we learned a special name for that. What's it called? Now, let's use the commutative property to write 2 multiplication sentences for the array. Ethan.
One sentence I wrote was 4 times 3 equals 12, since there were 4 rows and 3 columns.
That's great. And Kayla, what's the other multiplication sentence you could have written?
We could switch the factors and write 3 times 4 equals 12, since there are 3 columns and 4 rows in this array.
Biggity bam. We know we can count by 3 to find the total. What other skip count could you use? Kayla.
I would count by 4s. 4, 8, 12.
I love it. I think you guys are ready to try one on your own. Skip count by 3s 6 times. Write the 2 commutative multiplication sentences that represent the array. Ethan.
3, 6, 9, 12, 15, 18.
Awesome. Kayla, take it from there.
Since I had counted 6 groups of 3, I drew an array that showed 6 rows of 3 circles.
Nice. Ethan, finish it off strong for us.
I knew from the commutative property that I could write two multiplication sentences for the same array. So first I wrote 6 times 3, which I know is 18, to represent 6 rows of 3 circles. Then I switched my factors and wrote 3 times 6, which is also 18.
Yiggity yow. High five if you got it right. If you made a mistake, it's all good. The good news is that I've got another problem to give you another chance. Draw an array that shows 5 rows and 3 columns. Write a multiplication expression to match the array. Your array should have looked like the one here.
I wrote 5 times 3, since I knew there were 5 groups of 3.
Awesome. Now let's mix it up again and rotate this array and see what we can do with it. What's the difference between these two problems?
The array turned, and the factors in the multiplication sentence switched places.
Yes. Ethan, why'd the factors switch places?
In the first one, the 5 is the number of rows, and the 3 is the number of columns. When the array rotates, there are 3 rows and 5 columns.
That's right. The total in each array is... Ethan.
3, 6, 9, 12, 15. So I know there are 15 circles in total.
Awesome. Kayla, how did you skip count to solve the second array?
I skip counted by 5s because there were 5 circles in each row. 5, 10, 15.
Nice work. Today we did some big-time math. We worked with arrays to show the commutative property, and we saw just how useful skip counting could be in solving multiplication facts. Ready to show your skills? Then let's go to the Tower of Power.